Hello, everyone. The world of artificial intelligence changes every month. We started with ChatGPT, question and answer, then moved to LangChain, a linear chain of steps. And today, we are in the era of autonomous agents. But how do we make 5 AI agents work together like a company team, discussing ideas and correcting each other's mistakes without the system collapsing? The secret lies in one tool that changed the rules of the game: LangGraph. In late 2022, a revolutionary library called LangChain emerged, created by a brilliant engineer named Harrison Chase. The idea was simple yet groundbreaking. Instead of sending a single prompt to an AI, why not link multiple steps together in a chain? Imagine you're building a robot to go shopping for you. The chain would look like this. Step 1, find the product's price. Step 2, compare that price to my budget. Step 3, if it fits, buy the product. This approach was brilliant, but it had a limitation. It worked in one direction only, like a train on a straight track. It couldn't go backward or easily change its course. In programming, we call this a DAG, a directed acyclic graph. Data flows from A to B to C, with no chance of returning. The crisis: when AI makes a mistake. Here is where the real problem started. AI isn't perfect, and it often hits dead ends. Imagine this. You ask an agent built with the old LangChain to search Google, and then summarize the results. The agent goes to Google, but finds nothing, no results. Because the system is a linear chain, the agent doesn't know how to go back, change the search keywords, or try a different strategy. The system simply freezes, gives a wrong answer, or the code crashes. For a long time, developers tried to fix this by writing hundreds of if-else statements. If the search fails, try again. If it fails a second time, try a third way. This turned the code into spaghetti code, a messy, chaotic web that was impossible to maintain. The solution: the birth of LangGraph. The team at LangChain realized that smart agents need to think like humans. We don't think in straight lines. We try, we fail, we take a step back, we correct our path, and then we try again. This is where LangGraph comes in, introducing the power of cycles. The word graph means we are no longer trapped on a straight track. We now have a full map. An agent can go from A to B, and if it discovers a mistake at point B, it can loop back to A or move to C, and then return to B. Simply put, LangGraph transformed software from a one-way train into an expert coach. A coach who manages a team, monitors the results, and tells the agents, this result isn't good enough. Go back and try again a different way. The bottom line: old LangChain equals sequential steps, no turning back. New LangGraph equals steps, plus the power of cycles and self-correction. How does LangGraph actually work from the inside? Imagine you're running a small company with a dedicated team. LangGraph consists of 3 main parts and no more. Once you understand these, you've mastered the whole game. The first part is the state, or the shared memory. In regular programming, information often gets lost between steps. But in LangGraph, the state is like a giant shared notebook that the entire team keeps on the table. Every piece of information, every search result, and every line of code is written in this notebook. When any agent starts their job, the first thing they do is read this notebook to see what happened before them. When they finish, they write their results back into it. Simply put, the state is what makes the AI remember and understand the full context of the work. The second part is the nodes, which are your specialized employees. Every node is essentially a worker with one specific task. Think of a node called the researcher. Its job is to take a question from the notebook, find the answer, and bring it back. Another node might be the translator, whose job is to take that information and translate it. In LangGraph, the node is where the action happens. Technically, it's just a function, but mentally, it's a worker in your smart factory. The third part is the edges, the traffic manager. These are the paths that determine who hands the work to whom. Without edges, you would have great employees who don't talk to each other. Edges are the rules that say, once the researcher is finished, take the results and go to the translator. They are what connect everything together and make the whole system flow. Why do major companies pay millions for LangGraph? Simply because it possesses superpowers that make building complex systems nearly impossible without it. The first of these powers is persistence and memory, better known as checkpointing. The system automatically saves its state at every single step. Imagine if the server suddenly crashes in the middle of a long task. With LangGraph, you can simply restart from the exact point where it stopped, just like a time travel feature in a video game. This ensures that no effort or data is lost due to any technical failure. The second power is human in the loop. Let's say you have a smart financial agent that suddenly decides to transfer $1,000. LangGraph allows you to pause the agent before execution, send an alert to a human manager for approval or rejection, and then the agent continues its work based on that decision. This feature is what makes AI safe, reliable, and ready for use in sensitive business environments and large corporations. The third power is streaming. Instead of waiting for several minutes in front of a blank screen for the final result, LangGraph gives you the ability to see the agent's thoughts and steps one by one as they happen. This transparency gives both the developer and the user a sense of confidence and full control over the process, as if you are watching your team complete their tasks right before your eyes. To wrap things up, I hope you now have a solid handle on LangGraph's architecture and logic. Mastering the structure is the first step for any engineer looking to stand out. Next time, we're moving from theory to action. We'll build a full multi-agent system from scratch using the vibe coding approach, turning these complex concepts into real working code. Catch you in the next one.